Hello, my name is Chris Lemons. I am the Executive Sales Manager for Emitted Energy. I want to take a moment to welcome you to this Teledyne Flir webinar series hosted by Emitted Energy. In this webinar, we will be focused on automated infrared inspections for quality control, packaging, and food safety manufacturing. Thank you for your time, and I hope you enjoy the webinar. There's a lot of different elements that go into making good product and safe product. A food manufacturer relies on good ingredients, good equipment, sanitation rules, regulation, good people and processes, but there's one underlying parameter that really expands all production applications, and that is temperature monitoring. Being able to monitor and control temperature is critical in all aspects of food production. Diving into the subject of temperature a little more deeply, there's several heating and cooking concerns that are going to come into play, such as ensuring that the food is properly and thoroughly cooked. Manufacturers want to ensure the food is heated adequately to kill all the bacteria and any other pathogens that might exist. To do this, you need to ensure that there is uniform temperature distribution, not just across an individual product, but also across the entire line, so that the product on one side of the line is the same as it is on the left side or the right side or the middle of the line. Now, obviously, eliminating bacteria and pathogens that will result in product quarantine is obviously essential, but we also want to ensure that the food isn't overcooked or burned. Overcooked product can result in dried product or a product that is damaged in other ways and must be discarded. Now, as important as cooking to the proper temperature is when it comes to the freezing and chilling process, we also have some concerns that require monitoring. Ensuring that the product is properly frozen prior to packaging and storage is very critical. Some products require a certain level of chilling to occur prior to getting it ready for distribution. Cheese is one that comes to mind. It's one of those products that if it's not correctly chilled, it becomes mushy if it's a little too warm, and if it's over chilled, it can result in hardness. So therefore, it is important to monitor temperatures of the product at different intervals in the process. So it's not enough to just collect said temperatures using randomized sampling. That only provides a small portion of data and will result in higher amounts of waste. If a product is found to be non-compliant, this leads me to my next point. The current method of collecting temperature contains much variation and only accounts for a small collection of data. This process is similar across all food manufacturers. An individual will scoop the product directly from the line and collect a contact measurement using a temperature probe of some kind. The samples are typically taken 4 to 6 times per hour, and the data is manually recorded in the system to track these temperatures. Now, besides only collecting a small portion of data, there's additional variation related to this process to overcome. Some operators will scoop the product from different areas on the belt based on the size, based on their size, individual size. A shorter operator will tend to get closer to the edge, and a taller operator will scoop samples from the middle. Also, the variation is introduced when using the probe. Some operators may push the probe into the product deeper than others, which will cause the temperature variation. And then, of course, operator fatigue will always play a role in any manufacturing process. The closer to shift in, the operator will tend to cut corners or speed up the inspection process. In the food industry, it's essential to carefully control the temperature and shape of perishable goods throughout the manufacturing process, from production to transportation and storage all the way to the sales. Food processors need tools that automate crucial operations in a way that helps minimize human errors while reducing costs. The Thermal Process Monitoring System is a process monitoring system designed specifically to automate the food manufacturing safety and packaging validation. It is a system that employs only the best Teledyne Flir infrared automation cameras to provide a non-contact temperature measurement, collecting literally millions of temperature readings per second. Each individual frame of picture that the camera takes is between 76,000 and over 300,000 temperature measurements in a single image. Now, those images can then be saved to be recalled later for additional advanced post-processing and analysis. Utilizing Enlighten software, the TPMS uses your custom parameters to identify faults in your process, using limitless regions of interest to monitor, alarm, and send triggers to the PLC to control the process. This control enables automatic adjustments in the process and alerting operators and managers to process variations and faults. All of this thermal data is gathered 24/7, and it can provide pivotal information on your process. Automatic reports can be generated using our SPC feature Aware, helping you to understand process trends that may adversely affect your quality control. Now let's discuss some of the features of our thermal process monitoring system. There are some basic applications where we may employ just a single region of interest. In this case, we're just monitoring the temperature within that single area. If the temperature goes above or doesn't meet a desired threshold, the system immediately notifies the customer. The system can also halt the process altogether or connect to a PLC to make the proper adjustments for a closed loop system. Data collected within each region of interest collects min, max, and average temperature. This data is stored for data retention and analysis. The system is not just limited to one area, however, but can monitor multiple zones across the line. So instead of just monitoring one large area, we may want to put an individual zone across the line to understand and monitor what's happening in individual lanes, such as left, right, and medium, or the middle. All of the alerting and alarming capabilities are still the same. The system is just giving you much more data at that point. Again, if you have an alarm or an alert, those can be sent via text or email directly to the people that you want to get the information. There are some applications where our customers require more advanced capabilities. Our Enlighten Plus package delivers additional vision tools capable of achieving customer expectations. By using machine vision tools, we can not only monitor the temperature, but also recognize individual product location based off shape recognition and other non-temperature related product issues. We can identify overlapping product that may indicate an undercooked scenario. We can identify cold spots on the cooked product that may have resulted from shrapnel in the process. Equipping our TPMS with other vision tools such as 3D scanners helps us to identify food uniformity as well. And of course, all of this data is stored in our system and can be output to our Aware SPC package to run training analysis reports sent directly to your inbox. This expands our capabilities well beyond our typical applications. Now, we traditionally used thermal monitoring on products like pre-cooked bacon and sausage crumbles, pre-cooked meats like burgers and sausages and chicken patties, snack foods like pizza rolls and egg rolls. And on the chiller side, I had already mentioned previously about the cheese and the dairy applications. Those become pretty apparent, but also frozen appetizers such as French fries, onion rings, anything that needs to be frozen and brought down to the temperature before we can go off and store it. So once the product has been cooked or frozen properly, there are still other processes that need to be thermally monitored. The food can be properly cooked or frozen, but if the package is not sealed properly, it's all for naught. One of the first types of packaging I would like us to look at is the box seal quality. Boxes used in food storage must be sealed properly, and most of the boxes get sealed using a glue bead of some kind. For that box flap to be glued properly, the glue must be at a certain temperature and in the correct dispensing location for it to adhere to that other flap correctly. Quality issues that can occur during this process is things such as dispenser issues like a clogged nozzle, which could cause gaps, splatters, or incorrect glue volume. There are several other problems that can start to arise, most of which are temperature related or can be seen with thermal imaging. One of the cool things about box flap monitoring is we're not actually going to perform it by looking at the glue, which would be considered a pre-process validation. We actually look at it after the other flap is closed over the top of it. The energy that emits from the hot glue conducts through the surface, making it easy to see patterns that may define a poor seal. We can also monitor the size of the glue patch and how many pixels, we can do this by measuring how many pixels meet this certain temperature requirement, which can help us ensure that we've got a good quality seal, of course. From there, we can alarm if the glue patch is too large or too small, and create databases for that information. So another type of packaging that I want to talk about is induction seal applications. Now, this application involves taking a screw-on cap of some sort that has a small foil cap seal residing on the inside of the cap, and that typically has some adhesion on it. This bottle or container is then passed under an induction heater that creates a current that produces heat within the seal itself because of the resistance. Now, if we've got a good seal, it's going to have a nice uniform temperature band or ring. The thermal image is going to show up really clear and really crisp. If the seal is bad, it's going to result in a very non-uniform pattern. We're going to have missing areas signifying no seal or a poor seal. And then in other instances, we're going to have too much heat in an area. All of these issues are going to be caused by things like missing foil, cutter damage, seals misaligned, or equipment failures. In short, thermal cameras are going to be able to catch all of these issues. Now, whether it's a snack pack foil seal, bag seal, foil pouch seal, or other types of packaging, the Flir powered TPMS is an effective way to measure seal integrity. The TPMS was designed to control and analyze the manufacturing process. We do this through data. Thermal imaging sees what the eye cannot see, so if you're not implementing thermal imaging on your line, you are missing valuable data that can be used to improve your processes and quality control. Data drives every important decision in our lives. Think about it. Doctors build treatment plans for you based on your health records. We use smartwatches to track how many steps we've walked. How many times have you cooked a turkey without a temperature pop-up probe? I mean, we plan certain activities around how the weather looks for the day by reviewing the forecast prior. Data drives smart decision making. My request to our audience is very simple. Use the powerful data gained from the thermal imaging to improve your process and quality control. Emitted Energy is proud to be a trusted partner with Teledyne Flir. The best thermal imaging cameras allow you to explore the world in a whole new way, allowing you to see, measure, and capture temperature differences accurately and from a safe distance. Whether you're looking for a fully integrated thermal process monitoring system or a thermal camera to monitor a condition, Flir has so many solutions to meet your needs. If you're looking to detect refrigerant and gas leaks, the GF77 is the perfect solution. The SI124 can be used to detect compressed air leaks, and the E96 and the C5 are the perfect compact handhelds used for mechanical and electrical utilities inspections. Other thermal camera applications include early fire detection and 24/7 condition monitoring of critical assets. Now, if you would like to learn more about these and other solutions, please visit our website at www.emittedenergy.com. I hope you've enjoyed this webinar on automated infrared inspections for quality control, packaging, and food safety manufacturing. If you would like to set up an application discovery with my team, or learn more about your specific application and how thermal imaging can help you control and analyze your process, please feel free to reach out to us at sales@emittedenergy.com or call us at 855-752-3347. Again, thank you for your time.